Hi everyone and welcome to STEM School. Now in today's video we're going to be looking at the rules of surds. So there are a few concepts you need to grasp that you'll use very often in topics like algebra for instance, and I'll do plenty of examples to show you all how to tackle it. And there's not that many dedicated exam questions on surds, just mainly for rationalising the denominator, which is something you'll see in my next video. So first things first, what are surds? So a surd is just a number that's left in square root form. So for instance, we can have root 5, we can have root 7, okay, these numbers are surds. And what sets these numbers apart is that these numbers are irrational, which means you don't have an exact answer, and you can't write it as a fraction either. So in other words, if you were to write these numbers, root 5 and root 7, as a decimal, it would go on forever. So let's try that. If we were to put root 5 into a calculator, what would you get? You'd get 2.23606 and so on, okay? So it will go on forever. And then let's try root 7. You'll get similar idea, you'll get 2.64575, okay? And it would keep on going. Now, it must be said that not all numbers that are left in a square root form is a surd, okay? So these numbers here, we've got root 4, we have root 9, and we've got root 25, and root 16, okay? So these are square numbers you should recognise, and these numbers are not surds because we can simplify this down, and what we have is a rational number, it's an exact answer. So root 4 will become 2. Root 9 will become 3, root 16 will be 4, root 25 would be 5. Okay, so when it comes to the surds topic for the exam, you just always have the list of square numbers in your head. So you just have to remember it's 2 squared, 3 squared, 4 squared, 5 squared, and so on to get that list. Alright, so let's do something useful and look at the rules of surds. We have 3 rules here that you're going to be using very often for this topic. Now let's look at the first rule. So the first rule states that if you multiply a surd by another surd, then the answer is just the surd of the numbers multiplied together. So let's do an example to show this. So we have root 8 multiplied by root 6, for example. What you do is just multiply the numbers that are being square rooted. So 8 times 6 is 48. And then remember you have to put the square root over it. And there we have it. So that's that answer. Now let's move on. So we've got root 7. We'll do another example. We have root 7 times root 5. So same process as before. 7 times 5 is 35. And then you just put that in a square root. Now let's move on to the second rule, which is very similar to the first rule. This rule states that if you multiply a surd by the same surd, then the answer is just the original number before it's square rooted. So I'll do an example using the logic from rule 1 to prove this. So if we have root 8 multiplied by root 8, same as before, 8 times 8 is equal to 64, and you put that in a square root. Now you should recognise that 64 is a square number, so root 64 is simply 8, and that ties in nicely with this rule just to prove it to you. And lastly, we have the third rule that we're going to use, which is to do with dividing surds. So if we have a fraction of a surd over a surd, you can just take the square root of the whole fraction. And this rule actually does come in handy for future non-calculator exams. So if we had root 8 divided by root 2, if you saw this in an exam, you won't know how to figure it out. But if you remember this rule, we know that we can write the numbers as a fraction, so we can write 8 divided by 2, then put the square root over it. Now in this form, we can figure out the fractions separately, so 8 divided by 2 is 4, then put the square root, and root 4 is simply 2. So these are the rules of surds. The next aspect we'll look at is simplifying surds, which can come up in exams. And the aim of this question is to make the numbers in the square root as small as possible, and we're going to be using these rules that we just went over to help us do this. So the method to work this out is to split the number being square rooted into a product of at least one square number. So in other words, you have to ask yourself which one of these square numbers multiplied by any other number makes a number in the square root. So let's do an example to help us understand this. We've got root 45. We have to simplify it. That will be the keyword that they use. So which one of these square numbers multiplied by any other number makes 45? Well, I know that 45 can be broken into 9 times 5. Okay, so 9 is a square number that I'm dealing with. So we just rewrite it in this form of this rule that we just went over, rule 1. So we can say root 9 times root 5. Okay, and then since we have a square number and a square root, we know we can simplify this. So root 9 will be 3, and then we can't simplify the root 5, so it'll just be 3 root 5. And you know you've simplified it to its max because you know you can't simplify the surd anymore, okay? So let's move on to an exam question this time. Very similar idea. We've got to simplify root 50. So which square number multiplied by any other square number makes 50? So I know that 50 can be broken down into 25 times 2, okay? So we can rewrite this as root 25 times root 2, just in this form, okay? And then as we have a square number and a square root, we can simplify this down to 5 root 2. And that's as simple as you can make this answer. So we'll now look at adding and subtracting surds. And for this rule, you need to remember that you can only add or subtract surds if they are like surds. So you can think about it like algebra to understand it better. And you could potentially have to simplify the surds so that we have surds of the same type, and then we can add or subtract them. And we'll be doing that in this first question. What we have to do is use this process of simplifying surds that we just went over to do that. So what we have here is root 63 times root 28. So we can't subtract these right now because these are not like surds. These are totally different numbers. What we have to do is simplify them. And the clue is that they're quite big numbers, so it kind of implies that you should simplify them anyway. So we have root 63. What square number times any other number makes 63? So I know that the square number of 9 can be used. So 9 times 7 is equal to 63. Okay? Now do the same thing for the 28. I know that the square number of 4 comes in, and we have 4 times 7 is equal to 28. So same as before, we rewrite it in this rule, rule 1. Okay, so we can write root 63 in this form. So we have root 9 times root 7 minus root 4 times root 7. Okay, and you'll notice here that we have a root 7 here and a root 7 here. This means that we have like surds and we can subtract them. But first of all, we can actually simplify this down. So we have root 9 can be simplified down into 3. So we have 3 root 7 here. And then the root 4 can be 2. So 2 root 7. So we have two like surds, so we can simplify it. All you have to do is subtract the numbers in front of the surds, okay? So 3 take away 2, and that will just be 1 root 7, okay? But we don't normally write the 1 in front, okay? That's just normal practice for it. But another way of thinking of this, if I replaced root 7 with x, and you did it like algebra, it'll be 3x take away 2x, and you'll know that'll just be x, okay? Now let's do this example. We've got 8 root 3 plus 4 root 5 take away 2 root 3. So we've got like surds, right, but only for these the first and the last term. Okay, we've got a root 3 here and a root 3 here. So let's rewrite it to make you understand it a little bit. So we can replace the root 3 with x, so we have 8x. Then I'll replace the root 5 as it's different with y. So we have 4, I'll make that y. So 4y take away 2x, okay? So you can only subtract the like surds, so 8x take away 2x. So for this, it will be 8 take away 2, the numbers in front, so it'll be 6 root 3. And then we can't do anything with this 4 root 5 because it's different, it's not a like surd. So this is the final answer. Lastly, we'll look at multiplying surds, and the easiest way to do this is, if it's possible, you simplify the surds first, then you multiply the numbers in front of the surds, and then use rule 1 and rule 2 to multiply the surds themselves, so you kind of treat it like two different parts. So let's have a go at this. We've got root 20 multiplied by root 90. So these are quite big numbers, and it kind of implies that you should simplify them. It's easier to simplify them rather than multiply at first because you'll just get a big number, okay? So what square number multiplied by any other number makes 20? So the square number 4 can come in, so I have 4 times 5, and that will equal 20. So I've tackled that. Let's do the 90. What square number times what makes 90? So I know that the square number of 9 can come in, so we have 9 times 10, okay? We just rewrite it in the form of rule 1. So root 20 is the same as writing root 4 multiplied by root 5. And then what we're going to do is to multiply it by the root 9 by root 10. Okay, so I've rewritten it in the same process of simplifying surds. So we can simplify this now. So we can do 2 root 5 multiplied by 3 root 10, okay, because it's root 9. So all you have to do now is multiply the numbers in front of the surds. What you'll get is 2 times 3 is 6, okay. Now we're going to deal with the surds. I'll write it to the side here. What we're doing is you're multiplying root 5 by root 10, okay, and we just have to use either rule 1 or rule 2 to figure this out. So this adheres to rule 1, so this will just be 5 times 10 is 50. Multiply the numbers in the square root and put that in a square root, so it'll be 6 root 50 as the final answer. Now, is this actually the final answer? Well, no, it isn't, because we can simplify this root 50 down, okay. So what square number multiplied by any other number makes 50? So I know that 50 can be broken down into 25 times 2. 25 is a square number here, okay. So we'll rewrite it, we'll simplify it down, so it'll be 6 multiplied, and I'll put it in brackets, so we have root 25 times root 2. And then simplify it down, so it'll be 6 times 5 times root 2, so it'll be, final answer is 30 root 2, and there we have it. Okay folks, I hope this video has helped you. Please do like and subscribe, and join me in my next video as we'll look at rationalising the denominator, which is a common exam question. So I'll see you guys then.